In the, as I said, you need to memorize certain thing. At least in the case of laminar flow through pipe, there are two cases. What is called as constant heat flux, and another thing is constant wall temperature. So how under what conditions these are how to always how to maintain constant wall temperature. So constant wall temperature means you can have a condensing fluid. No, fluid is a condensing or boiling fluid surrounding this tube. So by that way you can have a constant wall temperature. And in the case of constant wall heat flux, you can think of putting a this electrical heater. So for the heater, it will be supplying constant heat flux because of whatever the heat flux is based on the power supply. Is a power rating of that, or based on the resistance of that device, that electrical circuit. No, so by that way you can have constant heat flux, constant wall heat flux. That is uniformly for every meter square, it will be generating only that much of heat. Whereas Q is a constant for this uniform heat flux that is possible by electrical heater surrounding a pipe. Okay, and constant wall temperature is possible by putting by having a condensing fluid or a boiling fluid. So that fluids will be maintaining the surface at constant temperature because only phase change is happening to that fluid. So because of the whatever the heat removed or supplied, it will be the phase change will happen at constant temperature. So because of that, the wall will be available at constant temperature. Okay, and here for the case of laminar flow through pipe, there are already some fundamental from fundamental derivation. You'll be getting this end result like Nusselt number equal to this 48 by 11. You can see, you can easily say that since it is a kind of a whole number, these are all based on the derivation for laminar flow through pipe. From that, you'll be getting this Nusselt number for constant heat flux conditions. So this is 48 by 11, or is sometimes it is given like 4.36. So this Nusselt number is 4.36 for constant heat flux conditions. And one more thing, you can for constant wall temperature conditions, Nusselt number equal to 3.66. Of course, these two are applicable for laminar flow through pipe. Okay, for laminar flow through pipe, for the conditions of constant wall heat flux or constant wall temperature, you are given with a Nusselt number, which is a constant. Okay, these are all coming from derivations. Of course, this number 3.66 also is coming from some derivation, fundamental derivations. So the end result is only available. Okay, of course, for this number, lengthy derivation is also available in books, but let us not worry. We need to memorize these two values. Okay, for 3.66 for constant wall temperature and 4.36 for constant wall heat flux. Okay, constant wall heat flux is possible for by having what is it resistance heater surrounding a pipe material. Constant wall temperature is possible whenever there is a condensing phase change operation happening around the tube. Okay, so that sometime instead of mentioning this what is it constant wall heat flux or constant wall temperature, that terms will also be available. That will be indicating about these conditions. Okay, that's why I'm saying about that.